All right, we're back. I'm continuing with the series where I work through a programming problem as though it were an interview uh, in the effort to motivate both how I would recommend people practice code interviews as well as how you actually do them. An interesting side effect of doing this, by the way, of recording these for a friend of mine. This is honestly probably the best prep I could ever suggest to someone. Record yourself working a problem and then play it back and see if it's engaging. Remember, one of my main points while going through this process, one of my main points is that you should always try to engage the interviewer. This is not a test of your ability. What's happening during these code interviews is that they're trying to have a conversation with you anchored in code. So we're not going to have these hypothetical questions around, networking layers or shenanigans like that. We're going to have a real discrete, specific conversation about a specific problem and a specific set of code that you specifically wrote. And that conversation is really important. So one of the things that I'm really trying to target here is not just how do you solve these problems. How do you solve these problems is not particularly interesting. If you toss a little money at LeetCode, they'll tell you the solutions to the problems. The solution to the problem isn't really the important part. The important part is the conversation. So a big portion of what I'm trying to capture here is how to frame what you do during the interview for that conversation, and therefore how you should frame your practice in preparing for these interviews. So I've got this comment I've been pasting in every time. You may also notice that at the bottom of the description beneath this video, you should notice that there are these 4 points are going to be outlined a little more, because again, this is what I really want to be the takeaway, not the solution, but the act of having this conversation with someone. All right. And there's so many different opinions that people have on how to take these interviews and do them well, whether you should comment a whole bunch, whether you should extract lots of methods, and the reality is I've done hundreds of coding interviews, and the important thing is never did you put a comment in the right place. I've never once gone back to a hiring manager and said, hey, they wrote an excellent comment. Most of the time I go back to the hiring manager and say, I tried to help them and they still couldn't solve the problem. Because, and this is very important, it's a waste of my time if you just straight up fail the interview. I don't want to waste my time as an interviewer. I want you to succeed. If you succeed, we then have a choice to hire you. If you fail the interview, if you just can't produce working code, I didn't get any meaningful data to take back to the hiring manager. I want you to give me information that I can take back so that we're going to make an educated decision on whether or not to hire you. And that the keys I need are the conversation that we're having around the code. The code itself is sort of secondary, right? That's just the framework for the conversation. So I really want to approach it this way. I really want to talk from this perspective, and therefore I want to prepare from this perspective. Now, how do I recommend constructing that conversation? The first thing is to create the interface. This does not mean the Java keyword interface. This means the programming structure, the public exposure of the interface, right? So for a lot of the programming problems we're doing, this is going to look like a method signature. You want to do this as quickly as you can, sometimes even before asking questions at all, because you want to anchor the conversation in real, actual things, in code. You want to anchor that conversation in code as quickly as possible. You don't want the interviewer to hem and haw and wave their hands in the air and come up with vague statements. You want to be able to specifically talk about the method signature, specifically talk about the arguments and the return value. You want to be able to get to that very quickly so that you can talk about whether or not there are limits on different things, all sorts of stuff, right? You want to be able to talk about constraints in concrete terms. You need to have the context, and it's your responsibility to give that context as quickly as possible. So the first thing is create that interface. The next one, my claim is show how you would exercise that interface. That isn't always something you can just write as executable code, but the point is that would be a great comment if you're in a situation where you're like trying to you're doing a system architecture. How do you know if you've created the system architecture that someone's wanting to create some file sharing thing or something like that? Talk about the main use case, or even just an ancillary use case of exactly what you're being asked to deliver. How would someone use what you're being asked to create during the interview? The next thing is to very quickly get into a cycle where you can show progress. I refer to this as red, refactor, green. In a lot of the rest of the world, you might hear red, green, refactor. I think you are a crazy person if you refactor code that's working. Do not try to make things better once they're working. This life is just too short for that. And the problem is perfection is often the enemy of good. When they're asking you to write something, when they're asking you to write code, they almost certainly have follow-up questions they want to ask. You need to get it working and then shut up as quickly as you possibly can. You want to make sure you cover all your edge cases. You want to make sure you cover all of the nuances of the problem, but you want to complete it and be done so that they can ask their follow-up questions. And that's where, again, that's really where you're going to shine, when you can start having the conversation that they want to have. The last thing is be opinionated and be very clear about it. You don't have to back down. You don't have to be ashamed of your opinions. You will likely have to defend your opinions if they disagree. So if you have stuff that's really controversial, you're probably going to have to defend it. I have lots of different examples of these. One of my favorites is that exceptions are always control flow. That's exactly what they are. That is their function in programming, as control flow. So it's entertaining to get into those conversations sometimes if I do use an exception for control flow. You need to make sure that you do it explicitly and that you can, yeah, in other words, don't accidentally fall into it and then be like, oh, but I love using them, So the point is you should be opinionated, but you need to be able to justify your opinions. And that it's not just, well, I like it better. If you believe that every getter should get something, okay, but you need to be able to explain why, and it's got to be a better argument than Java Beans said so forever ago, right? Okay, cool. All right, those are the 4 things we're going to really try and capture here. This is the problem we're going to accomplish today. Again, I steal all these from LeetCode and just change them up a little bit. LeetCode is an excellent, 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 excellent resource. I'm not trying to take anything away from LeetCode itself. I am simply just looking to them for problem ideas. Again, the problem is sort of ancillary. I do link to it. The link will be also in the description. I do change the problems up a little bit. Hopefully, any solution that we come up with here would also be a solution for that LeetCode problem, but that's not always the truth. Okay, what do we have this time? Given the head of a singly linked list, group all the odd indexed values together, followed by the even. We're going to return that reordered list, and we have this additional constraint of order 1 constant space and order n linear time. So this is, I picked this one specifically for 2 reasons. The first is power has been off today, and so I don't have a whole lot of time to record this. And the second one is because it referenced Big O in the description itself. When you see these, there's a lot of complexity to Big O. That's absolutely true. What really is happening with Big O is just saying, hey, there's a math equation here. Think of this instead as some constant times 1 or some constant times n. So that's why I said constant time, because a constant times 1 is just the constant. And the n, the reason I said linear is a constant times n is a linear equation. Okay? So the point here is we are going to be given a linked list of some size. That size is n. Now they almost always do this where they don't really tell you what n is referring to. Great question to ask kind of up front because they're being sloppy. Right? So n is the size of the linked list. Order n here means basically you get a single loop. You can't nest other loops. We're going to loop through the linked list a fixed number of times. Right? So we're not going to loop through the linked list one time for each element in the list, or one time for each half of the elements in the list. We're going to loop through the list one time, or 4 times, but not n times, and not n over 2 times. We're going to solve this in order 1, so constant space. So that means we can have as many extra things as we want, but it can't be related to the size of the list. So we can have 1 thing or 2 things or 100 things or 1 billion things, but we can't have n things. Okay? So, remember we right now, for the purposes of this discussion, the tests are always going to be with the Java keyword assert. My recommendation is to never use any libraries that you don't have to. So things like JUnit would be out. What does our signature, what's our interface going to look like for this? We want to take, and I'm betting, we want to take some node, whatever our linked list node is going to be. Let's see, and odd even the root node. So we're going to take a root node and return perhaps some new root node. Okay. Well, now we need a node class. Class node. And the way that we're going to do this, it'll have a, let's go ahead and, just for the sake of doing this, it's going to have a public next and a public, let's call it, because I did ABCDs up here, we're going to just say it's a string value. All right, we need to be able to create a new one of these. So let's have 2 constructors. We'll have a public node. And just because we're going to chain a bunch of these together potentially, let's do this instead. This dot next equals next. This dot value equals value. And then we'll also have something where we're going to create this will be like a terminal node. And so it's just going to take a string value and return and set this next, or this, let's just go ahead and do it this way, value comma null, just to be explicit about what we're doing. Okay, so there's our node class. For the sake of our tests, so remember we're always going to run this. Java is really silly in that you have to turn on asserts. So you'll see when we run this, we didn't get an error, but we should have gotten an error if we were asserting that false is true. And to do that, we just come up here to our launch settings, copy it, paste it, save it, and run it. And now we get an error that says, hey, make sure you turn on VM marks. Cool. All right, so what we want to do is try to capture this example for our tests. So how are we going to do that? We want to pass odd even a new node. This is going to be A, comma new node B, comma, new node. See, and I'm already getting tired of typing this. So we're going to change this. We're going to have a public static node create list that's going to take vararg of strings, and then it's just going to say node root new node value sub 0. Yeah. How do we want to do that? Yeah, let's do that. New node value sub 0. So we're going to create it as though it's a terminal. And then we'll loop over the string. So for I equals 1, I less than values.length. Oops, got an extra semicolon in there. And we're just going to, let's have a node current equals root. We're going to do current.next equals new node values sub I. And then current equals current next. And then we're going to return root. Okay. Oh, cool. Public static. For this static method to see node, without a static on this class, it needed a reference to solution 4. So now we have it. So the point is we now can say create list A, comma B, comma C, comma D, comma E. And we want to assert that that equals create list. Uh-oh. Sorry, that was my alarm to go feed cows. Yeah. But we will try and hurry this up really quick, and hopefully the cows won't get angry. B, comma, D. Oh, right. And we have to do new solution 4. The things that yeah, you know, this is again, this is part of that opinionated thing for me. Factory methods, you know, from the patterns book, I almost always make a factory method be static. That encourages me to not save any data from this. You should never hold on to data you create in a static unless you're specifically trying to create something like singletons or flyweights or something like that. So, so the point is, it's just a habit for me to make these sorts of methods static, but the methods that someone's asking me for are usually part of some bigger context. We just don't know what that context is in the course of this problem. So I tend to not make these static, even though they almost never refer to any data outside of them. So that's why I'm tagging in the new solution 4 on this one, but not a new solution 4 on that one. Okay, here we go. We've got odd even equals this. And we'll leave this way for now. It's not going to be particularly useful. It's just going to fail and not give us any information. So it's just saying assertion error. Remember before we had colon and a string, and that returned that information here. But this isn't returning any information. We'll see if we can get by without needing it, because this is quite honestly a fairly straightforward problem that hopefully you've already started to pick up on how we're going to solve it. So we have a root. We're going to create a new root called even root. and this will equal root.next. Okay. Then what we're going to do is, well, we'll do it with, let's see, we want to have a node current even or odd. Let's do odd. Current odd equals root, and node current even equals even root. Then while current odd does not equal null. And we should probably have a null check, on odd even, like on the start, to make sure we aren't getting past null. We'll talk about that kind of stuff here in a little bit. So while our current odd is not null, then what we want to do is make it so that current even dot next. Oh, we are going to need to check. Well, let's keep going. Current even dot next equals current odd dot next. So what are we really doing here? Let's come back up to this guy. What we're saying is we're going to basically be starting looking at A. And what we want to do is suck B out of this and make A point to C. But we want to hold on to B. So that's why we've got these even things running around here. We want to hold on to the first guy. So the root next, that's our evens. We're going to hold on to them for a while. Okay. But when we yank this guy out, we want to make the current odd that we're looking at, we want to make its next point to the next of that guy. So basically next. Okay, so we want, well, and in fact, hold on, let's do this in order. So current odd is the one that we're working. So its next should be current even dot next. Right? So that's skipping over whoever the current even is. The next thing that we want to do, what is the next thing that we want to do? Yeah, how are we going to do that? It's current even dot next. And then current odd equals current odd dot next. So that's taking care of how the odds work, right? Because remember, whenever we want to bump forward to the next, the way that we traverse a linked list is just set the current equal to the current next. So this is how we're moving from A to E. But when we move from A to C. But when we move to C, we want the current even to have also updated to D. So the way that we're going to do that, how are we doing that? Is current even dot next equals current dot next. Current odd next equals, let's actually do that, current odd dot next. And then current even equals current even dot next. That's interesting. Because these look the same, my guess is there's going to be a way to sort of condense this. So whenever we're looking at Huh. That's interesting. Hold on. Let's take a step back. What we really want to do is go, when we're looking at A, we want to set A's dot next to C, but we want to hold on to B and also hold on to C. So let's not look at it as cur odd and cur even. Let's look at it as current and next. Yeah. And just to be really clear about what's happening here, we're going to make this root.next. So while cur is not null, then what we want to do is make next equal to current.next. Make current.next equal to current.next.next. And then make current equal to current.next. Or no, not that. We want current to be next. Yeah, so we want to hold on to whoever the next one is. Bump that, and then move to the next guy. And I think we really want to stop this. Once we're here on E, we don't need to process E. So really we just care while current.next is not null. So while current.next is not null, because if current.next is null, yeah, we're done. There isn't a reason to do it. Next equals current.next. Then we want to look at basically the one after that and bump it forward. This will exist because current.next is not null. So this one might be null and it might be setting it to null. That's fine. But then current is going to equal the odd or even one that's next. Interesting. So then the only issue is we need to handle, so there's sort of two problems. There's sort of what happens when there's an odd number of limit things and what happens when there's an even number of things. Comma F. And my suspicion is so when we get here, what we're going to do is current.next equals even root. But this only works if current was an odd. If current was an odd, then you need the previous one. Yeah, which yeah, I'm not 100%. So hopefully this is making sense. We're looping through. We're getting to the end of the list. This current.next is currently pointing at null. But the trick here is two of the current.next will be pointing at null. Right? We'll pick one up from this, and one of them is already pointing at null. So E is already pointing at null, and when we get finished with this loop, the D will also be pointing at null. And so then the question is, if we're holding on to a D, well, yeah, if we're holding on to an odd, then we want to, if current is an odd, we want to, then this even root should work that way. If we're holding on to an even, then this current.next is the wrong one, and we shouldn't have yeah, interesting. I don't see like the nice way to do it. Yeah, I don't see the nice way to do it. I am curious which one we've solved. So if we do this, we're getting an insertion error on line 57. But if we copy and paste this beforehand, well, or cut it, have we solved the even case? And we haven't. Interesting. Well, so let's add in a test method and see if we can't figure this out. Static void test. Let's do node input, node output, node result equals new solution for odd even input, assert. Oh, I'm sorry, I'm being dumb. Output. Otherwise, we have to do a result was not result. I'm being dumb. To do our assertions, we have to have an equals and a toString in here. A lot of IDEs, source actions, generate hash code and equals. Yes, regenerate it. Select the fields, next in string, okay. And we'll also generate a toString. Generate toString. Okay. And the way we will, I think let's do this the same way that we did above. So we're actually going to do value plus an arrow with a space plus next. And then the only difference is it'll point to null. So let's save that. And now when we run it, we got an assertion error. Oh, it's because I'm not using my new tests. So test, create list, comma, create list, and test, create list, comma, create list. All right, so we're getting interesting at, where was my test method? Oh, was not. Sorry, that's why. Was not output. There we go. Ace was not. Interesting. Okay, so this current.next is not doing. Oh, right. Yeah, so this is implying if we were to swap these back the other way. We'll talk a little bit about what was just happening there. Yeah, and so now it's failing on 99. Right. So this case is done just like we said, right? So the problem is this only works this only works on evens and the odds. So I'll tell you what, just to because I'm late with the cows, this is obviously not the most efficient way. But cur equals root. So now current.next is null, like it's here. We should return it, and all of our tests should pass. Okay. Again, this is not. This is obviously not great because I'm going back through it again. However, the constraint was order n time. This first loop takes, it's clear, order n, because we're looping over every element. We're visiting each element one time except for the last one. This is also order n because we're either visiting, or because we're visiting half. We're visiting half of the nodes to find the end of the even chain. And then we're setting, the end of the odd chain. And then we're attaching the even chain to the end of the odd chain and returning it. This way will work. Obviously, it's not ideal to loop back through the chain a second time when we didn't need to. So what we would need to do is sort of track our flip-flops so that we knew if we were in an odd or an even situation. The way I'm seeing to do that would be to add in two more nodes, an odd tail and an end tail or something like that, and then just sort of bounce back and forth between them. Yeah, even that sounds kind of gross. The other option would be to track the even indexes, track whether our index was even or not. And if it's not even, or if the current index is odd, or even, I don't know, that's why we have tests, you figure it out. If the current index is odd or even, whichever one is messing things up, you just don't do this cur equals next, but you're going to check for current.next not equaling null. So the point is you can just sort of track that way. The third solution would be to do what we were doing initially, which is compute both the even and the odd at the same time. So you're advancing 2 steps in each iteration of that loop, which is still order n. But then you will always know which one to sort of append to. So I feel like there are lots of different ways that you can do this that could result in something clean. This one I don't think was very clean because we're running back through it again. However, like I said, totally running out of time. And that's sort of the nature of this, right? Is you don't always wind up with the perfect result, and you're not supposed to. It's an interview. You're having a conversation, not proving that you're the smartest person on the planet, or the most gifted at logic problems, or the most insightful into exactly what happens. You might not, until you get to this point, realize, oh crap, right, I needed to keep track of which one was even and which one was odd. So you found this cool sort of like, I can simplify the code, and then discovered, oh, it didn't simplify the code. This is the reality of interviews. That's not why you're going to not get the job. I guarantee it. You got working code, you get to the end, they'll go back and say, hey, we talked about a lot. He had lots of different solutions to X. It's all about the conversation. It's all about being the kind of opinionated that they can take back to the hiring manager and say, hey, this guy cares about what he does. He cares about his craft. Here's an example of that. You absolutely want to have someone defending you inside the company. And that's just the best way to do it, is to have a great conversation with them. Not necessarily a great implementation of a thing you'll just literally never be asked to do ever again in your life. Okay. Hope you have a great one. I know these things get long. Hopefully it's valuable to you. And yeah, see you again for the next one.